Hello and welcome back. Let's talk about antiderivatives. So, what's an antiderivative? Well, to write an antiderivative, we would use this sign here. It's like an elongated S. And then we put our function here. Let's say x squared. And just like a derivative, we have to say, what are we anti-deriving? So we just use a dx. Very simple stuff. So, antiderivatives, it's just the opposite of a derivative. So if we took the derivative with respect to x of the antiderivative of f of x with respect to x, we would just get f of x. Very simple stuff. So let's get into calculating a few antiderivatives. Well, for example, the antiderivative of x squared dx, well, what can we derive that will give us x squared? Well, this is just a regular polynomial term, so we can use the reverse power rule, or the power rule for antiderivatives. So, with derivatives, we took x to the n, if we prime it, is going to equal nx to the n minus 1. Well, let's reverse this. So nx to the n minus 1, well, we know we're going to have an n plus 1, that's the opposite of n minus 1, and then we're going to have to divide, that's the opposite of multiplication. But order of operations, remember, we're actually going to be dividing by what we had before, which would be n plus 1. So the antiderivative of x to the n equals x to the n plus 1 divided by n plus 1. Pretty simple, but let's say we want to derive this, again, to make sure that this is correct. Well, that would make sense. If we derived x to the n plus 1, we get n plus 1 times x to the n divided by n plus 1 equals x to the n. But let's say we were deriving x to the n plus 1 over n plus 1 plus 4. What would we get? Well, the 4 would become 0, because if you derive a constant, you get 0, so you'd also get x to the n. Same thing if we added a plus 7, or a minus 2. So what do we say? Well, we use a general form, plus c, where c is any real number. So c could be pi. C could be Euler's number. And there's ways to figure out what c is, initial value problems and things like that. But let's go back to our reverse power rule. Integral, or antiderivative, I gave you guys a little bit of a teaser there. Well, this would be x to the 2 plus 1 over 2 plus 1 plus c. Don't forget your plus c. What are we going to get? 1 over 3 x cubed plus c. That's the antiderivative of x squared. Pretty easy stuff. Let's use another example. Let's say we've got antiderivative of cos x dx. What do we get? Well, we're going to get, what derives to give us cos x? Sine x. Good, right? No, plus c. So, you should be pretty much good to go if you caught that before I did. How about secant squared x dx? Easy. Tan x plus c. And so all you're really going to have is a derivative basically under there, and you're going to end up with the regular function. So these are just referring back to my old video called More Derivatives, I believe, where we just talked about a ton of derivatives and functions and what their derivatives looks like. So that's pretty much it, except for this one last one. Let's use the power rule. X to the negative 1 dx. What are we going to get? X to the negative 1 plus 1 over negative 1 plus 1 plus c. X to the 0 over 0 plus c. Well, that's not possible. Well, what derives to give us 1 over x? It's a little special one. It's ln x plus c. So hopefully you guys have caught on to the plus c by now and understand why it happens, because if I was to derive this again, derivative with respect to x of ln x plus c, it's going to give me 1 over x. Close to the same. So that's antiderivatives. Thanks for watching. Got 2 more videos for Calculus 1, and then we're on to the fun stuff, Calculus 2, and the even funner stuff, Calculus 3. So hope to see you guys in the next video and the next series. Thanks for watching.